No way you're going to submit it when it's almost 2:15. You should be submitting it before 2:15. Okay, anybody else having problem? Okay, guys. Now, somebody is also having problem. Okay. Okay, I keep on having to respond to your WhatsApp after this. I will not be responding anymore because I have my lecture to carry. I mean, I have to do my lecture. Okay, done. Guys, I'm not going to entertain your WhatsApp anymore. I already informed you guys that you got to do it before 2:15. It's a very short quiz. It's not a very long one. So that's it. Whosoever going to WhatsApp to me now, I'm not going to respond anymore. Okay. I'm going to have my lecture. I'm not going to receive it anymore after this, guys. So stop sending me your quiz. Because the time limit is already supposed to be 2:15. It's supposed to be a short one. So I'm going to, whatever you send to me by WhatsApp, I'm not going to respond after this. Because based on the time that I have given, I said it's supposed to be 2:15. So if you send it to me, if it's already beyond that time, I can only accept 2 minutes. That's it. Okay, guys. You didn't finish the question. Very short one. It's not supposed to be a long one. Okay, I'm not going to entertain your WhatsApp. Come on, guys. I'm going to start my lecture now. Yeah. Okay, now, where is my... I'm going to share you guys my for today's lecture. I'm going to start on psychometric chart or humidity chart. Okay, guys. Today is a bit different from what we have done so far. We'll be looking at psychometric chart, or another name for it is humidity chart. It's a chart for a gas vapor system. But most of the time we'll be looking at, if you look at my notes, you'll be looking at, oh dear. Okay. We'll be looking at water system, because that's the most common the most common system that we're going to encounter. It's going to be air plus water vapor. It's just not liquid water, it's water vapor. Right? So you'll be looking at a psychometric chart of air water vapor. The mixture should be at 1 atm. So from that chart, you will be looking at various variables. For example, you'll be looking at wet bulb temperature. Okay, wet bulb temperature. Dry bulb temperature, dew bulb, and there's another one, dry. Okay. Oh, the symbol is almost the same. It's double D. Both of them. So I would suggest, in order to differentiate the two, let this be dry. Let this be, sorry, this should be dry. The other one is dew. The other one is supposed to be dew. So let me erase this. Okay. So this is going to be T dew. Just write it dew, in order to differentiate, because it looks the same. This is D, this is D. So better not use the symbol given here. Just write in full is dew temperature, dry temperature, and if you want to prefer to write it full, then that will be T wet. You will be getting these informations from the psychometric chart. And how does the psychometric chart look like? Have you come across a psychometric chart before, guys? Anybody? Have you come across a psychometric chart before? Nobody going to respond? Hello, guys. Don't tell
No,
me.
doctor, I haven't.
No, you haven't. Okay, good. Then at least somebody responded. This is a psychometric chart. This is how it looked like. Okay. So let's look at it. You have so many axes actually in this one graph. So many. Let's point some of them out first. This is your dry bulb temperature. Let me highlight it. This is your dry bulb temperature. Yeah, that's your dry bulb temperature. But from that same axis, the x-axis, you can also get your wet bulb temperature and also your dew point temperature. So you can get it from the same x-axis. Okay? So another axis, the y-axis is the moisture content. The y-axis is the moisture content, or another name for it is absolute humidity. So if you look at it, the unit is kilogram. Actually, that unit should be kilogram water. There should be water there, kilogram water. Water vapor. It should be water vapor per kilogram dry air. So let me undo that. Let me write it. Okay, hold on. Let me rewrite it. I think this is using black. Okay. It should be kilogram water vapor per kilogram dry air. So that is the y-axis. Okay, that's the y-axis. And beside that, you have other values in this graph. You have the enthalpy at saturation. Okay, you have the enthalpy at saturation. And you have the wet bulb temperature. You can read from the curve. This is the wet bulb temperature or the saturation temperature from this curve. So if you draw a line here, let me see if I can use a red pen, red color. This is the saturation curve. That's the saturation curve. Yeah, I'm not doing very well there. That's the saturation curve. What else is there? Okay, let's use a different color. Green. What you have over here, you have this slanting line. You have that slanting line. That slanting line is actually the, let me undo that. I can draw a straight line. Okay, that straight line, that slanting line is actually humid volume. So I can, if I can highlight it, that's the humid volume. The volume of the air plus the water vapor per unit kilogram dry air. Have a look. Everything is based on per unit of dry air. That is the humidity per unit of dry air. Your humid volume is also per unit of dry air. Your water air content is also per unit of dry air. So everything is almost per unit of dry air. So beside the humid volume, let me change a different color now. Let me use blue. You have the curve. Okay, let's have it, this curve. Oops, undo that. This curve, why is it green in color? I haven't changed it, sorry. I thought I just changed it just now. Okay, this curve is the deviation of your enthalpy. Why is there a deviation of your enthalpy? Because the value that is written here is for saturated value. So if it's not saturated, then you have to deduct it using the value on this curve that I'm drawing now. That value is written as minus, for example, -2. So what you get here, for example, is 55. That is for saturation value. So if your point is somewhere here, then you have to get 55 minus 0.2. I will show you guys how to do that, but that's, you have this blue line, this blue curve, which is the deviation. Where is the line? Where is the deviation? Okay, let me highlight it. Let me highlight it. That is this enthalpy deviation. Okay, that's the enthalpy deviation. That is the value you need to deduct from the saturated enthalpy. The saturated enthalpy is over here. That's the saturated enthalpy. Okay. You get your enthalpy from this graph. Beside that, you also have another curve. Okay, I'm going to write down the curve that just now I mentioned you guys. This is 100%. This is 100%. Oops. This is 100% curve. Let me have it in red. This is the 100%. This is the 90%. That is the 80%, and so forth. 70, 60, 50, and it goes down and down until you have the 10%. This is 20. This is 30. The percentage is referring to relative humidity. Okay, the percentage is referring to relative humidity. So these are the values that you can get from the humidity chart. So let's get back to our lecture. You can get relative humidity. The symbol is HR. Saturation enthalpy. The symbol is capital H with a subscript S. Okay? You can have absolute humidity, small h with a subscript A. That is absolute humidity. And beside that, you have the humid volume, which is written as capital V with a cap subscript capital H. So that's are the values that you can get from the psychometric chart. Okay? So why are we looking at psychometric chart? Because you'll be calculating the energy balance involved in humidification, drying, and air conditioning process. So you'll be looking at these processes and calculating the energy balance. Okay, so let's now, if you look at your psychometric chart, just look at the one that I have over here. Let's zoom out. You will notice that the reference state of your chart is as written at the bottom of the graph. Okay, so let's zoom in. The reference state is water in the liquid phase at 0 degrees C, 180 M. That is for water because you're looking at water vapor. Even though you're looking at water vapor, but the reference state is liquid water at 0 degrees C and 180 M, and your dry air is at the same temperature and the same pressure. Okay, your dry air, of course, it's gas. There's no way you can get liquid AA. So then you don't need to write down whether it's gas or liquid. It's automatically gas. Sorry, dry air is automatically gas. Okay, so that's the reference state. So every time you do your energy balance, if you're looking at the psychometric chart, you have to follow the same reference state as written on that psychometric chart. Okay, so that's the reference state. And this is what I just mentioned just now. You have the relative humidity, which is the curve over here. Yeah, that's the relative humidity. I did mention to you guys just now, so now it's just a review. So that's your relative humidity. You have the saturated curve, which is 100%, 100% relative humidity. 100% relative humidity is not written 100%, but you know it is 100% because it is saturated. Okay, so you should know, even though it's not written. And you have the enthalpy line. The enthalpy line is the one over here written in black. That is your enthalpy line. Yeah, so if you go back to your psychometric chart just now, where is your enthalpy line? Now I need to use a different color because we might get confused with too many colors. Okay, let's use this purple. Where is your enthalpy line? Your enthalpy line is this line that projects towards the enthalpy. So if I use that, no, just stick with that. That is your enthalpy line. The slanting line going towards the enthalpy rule and the value of the enthalpy. This is your enthalpy scale. Okay. Your enthalpy line is the one projecting diagonally or slanting towards the values of the enthalpies, going towards the left-hand side, slanting towards the left-hand side. That is your enthalpy line. Okay, so let's go back to our notes. So your enthalpy line is the one that is slanting here towards the left. Okay, that is your enthalpy line. Okay, so that's very easy. Your absolute humidity just now, your absolute humidity is written on the y-axis. That is your absolute humidity. The unit is kilogram water per kilogram of dry air. dA is an initial for dry air. Okay, so if you see it is written as D, capital A, that refer to dry air. This is dry air. Okay, that's referred to dry air. Okay, there's another line over here. If you look at this diagram, there's another line here. That line, if I can use a blue color, that line is, what line is here? This line. There's another line. Okay, what line is that? That line is the constant volume line. This is the constant volume line. If the one that I mentioned before this, the line that is, that's the constant volume. That's the volume, that's the volume, that's the volume. The one in green, okay, that's the volume, which is the humid volume. That's the humid volume. Okay, guys, it's a lot. The information on this graph is a lot. There's too many things on it. I mean, not that many, but it can get confused. So that's the reason why the notes, my note is simplified over here. Okay, you can see it's quite simplified. It's not that many, but we can still see what is going on. Okay. Besides that, you have, let's see, what's the difference between this graph and that graph. This graph, you have the humid volume, you have the relative humidity, and you have the enthalpy line. Over here, what else is given? What else? No, it's still the same thing, except that it has more lines over in this diagram. Yeah. So this is the same thing. It's the same thing, no different from what I have mentioned before.
Doctor?
Yes.
Does the relative humidity go above 100?
No. It will be saturated at 100. It will saturated at 100.
So maximum is
100%.
50% water and 50% air.
No.
That's maximum, right?
No. 100% saturation means the air is really saturated. You know, when it rains every day, the air is saturated. It's really full of water vapor. For example, it rains from morning to night. The whole day it rains. So the air in that area that rains the whole day, it is really saturated.
Saturated. But doctor, the thing is,
yes.
The thing is, relative humidity, right?
Yes.
It's kg of water per kg of dry air.
Not really. When you're looking at kg of water per kg
so
of dry
so
air,
it's the percent. It's like 100% where it can go maximum.
Yes, it means that relative humidity is relative to the maximum.
Okay, doctor.
Okay, if it's maximum, that is 100%. Okay, the amount of air that the amount of water vapor, the amount of water vapor that the air can carry at a maximum, that will be 100%. The amount of water vapor that the air is carrying, which is less than 100%, then it should be less than 100. I mean, the relative humidity should be less than 100%.
Yes.
If it's not the maximum
But absolute
value,
can go above 1, right?
it cannot go above 100.
Absolute.
Absolute? Oh, you mean absolute humidity?
Yes, doctor.
Yes, it can go above. Let's look at the real diagram. Okay, it can. I mean, this absolute humidity is the kilogram of water vapor. If you look at the y-axis,
So this is way less than 1.
It's kilogram of water vapor per kilogram of dry air. Normally,
is it possible that absolute will go above 1?
Can your amount of water vapor be the same as the amount of dry air? Can it be?
Yes.
Can it?
I'm not sure, doctor.
Because you're looking at the air that we have a vast volume of air outside.
So most probably not, right?
No.
Okay, doctor.
Okay, it will be just a small amount of water vapor. It's just a small amount. It cannot be too big amount of water vapor, because if there's too many water vapor,
but then where does this graph end?
Normally it's about 0.033. That's the maximum.
Oh, okay, doctor. Thank you.
Okay. You can imagine if there's too much water vapor, what's left? How are you going to breathe? You need oxygen. Okay.
I know.
Okay. Thank you for the question anyway. Anything else?
Thank you, doctor.
You're welcome. Anything else? Let's go back to the note. Anybody want to ask any other questions? All right, so if you look at the notes, I have uploaded it in e-learning. So you can still see this diagram in your notes. So if you have any problem with that, you can have a look at it. Okay. So now, what to do? There's a mention of dry bulb temperature. Dry bulb temperature is just an ordinary thermometer. You just have the thermometer sticking in mid-air, measuring the temperature of the air. Okay, just an ordinary thermometer that maybe you stick on your wall that will read the temperature of the air or the temperature of your room. Okay? But when you have a wet bulb temperature over here, if you look at the diagram, the wet bulb temperature has some sort of a wet cotton wool or a wet cloth sticking to the bulb of the thermometer. So when the wet cotton wool is sticking to the bulb of the thermometer and you have a flow of air, okay, flow of air passing by that thermometer, what happens is that some of the water vapor will evaporate into the air. Okay, some of the water vapor will evaporate into the air. So the amount of water vapor in this outlet in the air will increase. The amount of water vapor in the air will increase. Why? Because the liquid water from the cotton wool, which was wet, the amount of liquid water in the cotton wool will evaporate and increasing the amount of water vapor in the air. So that means initially you have a humidity that is less than, for example, maybe just give you an example. Initially the humidity was only 10%. Just give one example, 10%. So after you have placed the wet cotton wool on the bulb and a lot of water has evaporated, maybe it could increase to maybe 11%. The humidity increase. That means the amount of water vapor inside your air now is more than before. Okay? So what happened when the liquid water on the cotton wool evaporate, the temperature of your thermometer will drop. The temperature of your thermometer will drop. That's why the temperature is always, the temperature of the wet bulb is always less than the dry bulb temperature. It's always less than that. And how do you get the wet bulb temperature? For example, you start from this point. Yeah, you start from that point. And if you want to get the wet bulb temperature, you go along the wet bulb line. You go along the wet bulb line, okay, and then read it either from the 100% curve. There is a temperature listed there. So let's have a look at the actual graph. Okay, if you look over here, you have the temperature here, 20 degrees C. You have 25 degrees C. You can read it off the wet bulb temperature from the curve itself. This is why it referred to as the wet bulb or saturated temperature. Yeah? So you can read off from the curve itself the wet bulb temperature. But now go back to that notes just now. You start from your point, which I have crossed over here. That is your point. Okay? And if you want to find the wet bulb temperature, you must go on the slanting line. Either it's on the slanting line or parallel to the slanting line until you reach the 100% saturation. Once you reach the 100% saturation, you can either just drop off and read the, sorry, I need to draw a straight line. I'm trying to get a straight line. You drop off, you just drop to the x-axis, then that will be your T wet bulb temperature. Or you can also get it from the 100% curve. Either way, you can do that. Okay? So it will be the same. Okay? Let's after this, we'll be looking at an example. There's another temperature that is mentioned here. The other temperature is the dew point. If you remember, I'm sure you have come across this before. Dew points is when the water vapor in your air starts to condense. The dew point. Normally, you come across dew when it's very early in the morning. There will be dew on the grass. There will be you will see water droplets on your car screen. Okay, that is the water condensing in the early morning. Okay, so the dew point is when it starts to, the first liquid that start to condense is the dew point, the dew temperature, the lowest temperature, the temperature when it first start to form liquid. That is the dew point. So how to get the dew point? So if I erase this diagram, okay, not the diagram, I erase what I have written before. So how to get the dew point? This is, for example, is your starting point. Okay, that's your starting point, the same point as before. If you want to find the dew point, you go horizontally across until you reach the 100% saturation curve. Then you drop to the x-axis. That will be your dew point. Compared to the wet bulb temperature, you have to go slanting to the 100%. So if you go to the slanting line to the 100%, this is for T wet. That is T wet. This is T wet. This is T dew. That's the difference. Okay? If you want to get the T dew point, it must be horizontal. Why is it horizontal? Because the amount of water vapor, if you read from the absolute, the moisture content on the y-axis is still the same. You did not increase any water vapor in your A. You just cooling it off. You just cooling the temperature until it becomes saturated, then your vapor start to condense. That's why it has to be on a horizontal line. The amount of water vapor in your A is constant. That's why it has to be horizontal. But for the wet bulb temperature, why is it slanting? Because as I mentioned before, you have a wet cotton wool or a wet cloth, and the water evaporates. So that means you are increasing the amount of water vapor in the air. So that's why it's slanting. It's not horizontal. Your amount of water vapor is not the same as the initial content of that air. It is increased because the liquid water evaporates into the air. That's why your T wet, you obtain it using a slanting line. Okay. Any questions? There's two temperature here. You need to be familiar with this concept, or else you have problem understanding it. Your T dew, the amount of water vapor is still the same. For example, during the night time, the amount of water vapor doesn't increase. So as it goes towards morning, as the night goes towards morning, the temperature drops. So the first first water vapor that condense will be at the dew point. So the amount of water vapor initially is still the same throughout the night. It doesn't change. Nothing changed. The amount of water vapor is still the same. So as it gets into the morning, that amount of water vapor will start to condense because the temperature drops. Okay, so that will be your T dew or your dew point. That's the three temperature that you need to know. You have dry bulb, that is the actual temperature of the air. The wet bulb, when you're using a wet cotton wool attached to the bulb of your thermometer, and the dew point is when you cool down your air until it starts to condense. The first liquid that condenses will be at the dew point. Okay, not really exactly. The first water vapor that condense is at the dew point. Any question? Nobody? Any question? Okay, let's look at an example. You understand it better once you look at an example. Let me see. What example do I have over here? Example 1. Okay. This is the example. Oh, it should be on the first page. Now it's on the second page. Okay, in this example, we have a dry bulb temperature of, let me get, okay, 31 degrees C. That's dry bulb. So let's look at our diagram. Our diagram. Where is 31? This is 31. That is 31. Okay, so that's 31 degrees C. What other information do I have? The wet bulb temperature, that's dry initially. The wet bulb temperature is 18.5. So let's look at 18.5. Where is 18.5? Let's zoom in. This is 19. This is 18. So somewhere in the middle is 18.5. That is 18.5. Okay, that's your P wet. This is your P dry. Okay, so that's two temperature. Now, what do you need to find? You need to determine the relative humidity. Oops, undo that. Relative humidity. So how do you get your relative humidity? You need to get the intersection of the 2 points. Okay, now let me draw a straight line from the dry 31st 31 degrees C. Oops, no, I need to use this. Okay. I need to get a straight line. Trying to get one. Okay, that's a nice straight line. Okay. Now your wet bulb temperature is 18.5. I need to draw a straight line again. Right until 18.5. Okay, that's roughly 18.5. And remember, in order to get the wet bulb temperature, you must go through the wet bulb line. Where is the wet bulb line? Where is the wet bulb line? Anybody? Where is the wet bulb line or the wet bulb line? Anybody? Any suggestion?
The horizontal line.
The horizontal line? Okay.
Yeah,
If it's horizontal, that means you are not looking at any evaporation of water. You're looking at wet bulb. That means that the bulb is wet. There is water, liquid water on your cotton wool. So water is evaporating. So should it be horizontal or should it be others?
Slanted.
Slanted.
Okay, it should be slanting, isn't it? The slanted line. Which line? We have a few lines here. We have this line slanting also. We have this line also slanting.
The one between 50 and 55.
The one between 50 and 55. Okay. You mean the one between this line, you mean? Is it? Which line?
That's
Yes.
enthalpy here.
Which one? Okay, now I'm going to ask, then you answer, okay? Is it going to be this line or is it going to be that? Well, this is A, this is B. Which one?
I think B.
B. Anybody else? Saying it's not B, it should be A. Okay, let's go back to our notes. Okay. Let's go back to our notes. Okay, let's start from the beginning. Okay. Where is our constant volume? That is not a good example to show actually. Okay, this one. This is the green line. The green line, the line that I highlighted over here is the volume. That's also slanting. There's another line. This is another line. Okay. There's another line. And that line, the one that I just highlighted, is the wet bulb line. The line that is green in color, this one, the one line that is green in color, that is the specific volume. Okay. Can you see? The one in red in color, the one red in color, this is red in color, is the wet bulb line. Oh, you could hardly see that, isn't it? The red in color is written in, the red line is written in red bulb, the one that, let me erase this. Okay. That
No,
is,
we're not looking at the enthalpy line, right?
the enthalpy line and the wet bulb line is the same line. It's the same line.
Okay, doctor.
Okay. So if you look at this, the line that the one that I'm erasing now is green in color. The one green in color is the specific volume, which is written in green. Okay. The one that is green in color is the specific volume written in green. Okay. The one that is black in color is also the same as the one in red. Have a look. They are parallel, isn't it? Let's look. This is black in color, and it's the enthalpy line. Okay. There's the other line which is beside it is the red in color. This is red in color, and that is the wet bulb line, and it's parallel. So they are the same because they are parallel. They are the same. So let's go back to our psychometric chart. Now, which line should I be using? Let me see. I should be going to my example. Example. Where is my example now? I should be using humidity chart. The example humidity chart. Okay, here. Which line should I be using, guys? Should it be A? Should it be B?
A.
A. Why?
Because, as you said, the horizontal, the one for enthalpy and the wet are the same.
Yes, that's it. If you look at B, you'll be looking for the humid volume. That is the humid volume. Okay? If you look use that line which I denoted as B, this line, that is for the humid volume, because you can see at the very bottom here, at the very bottom there's a value of the humid volume. Okay, so that is not what you want. So I'm going to erase that. We're not going to use the B, the line for the humid volume. Okay, so we're going to use the A, the volume, the line that is for A. So since it's not exactly on that line that I denoted as A, you must get a parallel line to A. Okay, so it's somewhere here, parallel to A. So get a straight line. Oops, let me undo that. I need to get a straight line. I'm going to get a straight line here. Okay, can you see? We already managed to get a straight line. Okay. From the wet bulb temperature of 18. How do you know it's 18? This one is 15, 16, 17, 18.5. This is 19. So your wet bulb temperature just now is 18.5. So follow that line, which is I denoted as A. Follow that line, which is the enthalpy line. Parallel to it, if it's not directly exactly on that line, just draw a straight line parallel to that line until it intersects your temperature, which is the T dry, which is 31 degrees C. So that is your point now of interest. Okay, that is your point of interest. So what does the question ask for? The question
humidity, right?
Humidity, yeah, relative humidity. So now let's look at the point. Where is it exactly? Do we have a curve exactly on it? This is the curve. There's another curve.
So it's at 30%.
Is it 30%?
Oh, no.
This curve. Sorry. I got the wrong curve. Now I'm.
Yes, it's 30%. Okay. 30%.
Okay, hold on. Where is the curve? The curve is here. Okay, that's the curve.
Positive curve. Yes.
It's a bit less than 30, isn't it? It's lower. Less than 30, isn't it?
So probably 29.
Yeah, this is 20.
28, 29.
28, 29, 28, something like that. Kind of estimate it. Okay. So now let's see, what do I have written as the answer? Oh, I say it's 30. Well, it depends on how accurate your diagram is. I mean, how you draw your diagram. What I suggest to you guys, you need to photocopy a lot of this graph from your textbook. A lot. Because if you want to do the example, you want to do the problem, you cannot use only the one graph which is in your textbook. It will be too messy. You need to photocopy a few copies. So every time you do a problem, you can use that photocopy version. Okay, so that you will not spoil the one inside your textbook, because it will be a lot of example that you have to do, a lot of problem that you have to do. So better use a photocopy version of the graph. So that if you can erase, you can do a lot on that photocopy version. Okay, so that's my suggestion. So now we already managed to determine that it's about 20. If based on this diagram, it's not really on the 30%, isn't it? This is 30, not really on the 30% line, on the 30% curve. It's slightly less. It's about 29 maybe. Okay, but then if you give your answer as 30, it's good enough, because when you
That's an approximate, right?
Approximate, yeah, because this is just by visual. So how you read off your graph is just visual by visual. So it's not that accurate actually. Okay, now let's try to get the dew point. Remember what is the dew point? Anybody? What is the dew point?
Temperature that it condenses, the
Yeah.
water condenses.
The first temperature that when your water vapors first start to condense, when the first liquid drop start to form. Okay, so the first liquid drop start to form, the initial content of water vapor inside the air is constant. So in order to get the dew point, what should you do?
Draw a horizontal line.
Horizontal line, yes, from your point of interest. So your point of interest is here. Yeah, so you should to draw a horizontal line going to the 100%, going to the 100% curve. So draw that, and once it reaches the 100%, when it reaches the 100%, then, oh dear, I'm not doing a very good job here. Okay, then go down to your x-axis, which I need to, okay, unzoom it. Okay, go down to your x-axis and read off, oops, can I get a straight line? I can't get a straight line. I'm trying to get a straight line, guys. I'm not doing a good job here. That is not what I want because it's off the 100%. Should be here. Okay. Somewhere there. So where is it, Kelly? Can you see? Is it not a good thing, isn't it? It's not straight. Not straight. Let me try to zoom in.
Dr. I noticed this.
Yes.
We don't have to draw a straight line down.
Why?
We can just refer.
Yeah.
We can refer to the curve.
Yeah, there's 100% there, isn't it? 100% curve. Yeah, it's the same thing.
Yes,
Huh?
it's okay.
So this is 10. This is roughly about 11 degrees C.
11, yes.
11. Okay, so let's have a look at the answer. Is it really 11? 11.5. Well, this is off by 0.5. Maybe somebody did.
Because the answer is using from 30%, so it's slightly above our
Yeah.
point of interest.
Yeah, you got it right there. Okay, because the answer is supposed to be around 30%. We got less than 30, 29%. So it will be off there. Okay, so that's how you get the dew point. You must have a straight line. From your point of interest, draw a straight line until it reaches 100%. That's how you get your dew point. Okay, next. What is asked? What is what do you need to find? You need to find the absolute humidity. Where do you get the absolute humidity? Absolute humidity is the one on the y-axis. Sorry, on the y-axis. Okay? The temperature is on the x-axis. The absolute humidity is the one on the y-axis, or another name for it is the moisture content. Okay, so if you want to get your absolute humidity or moisture content, all you have to do is draw a straight line from your point of interest. Yeah, from that point of interest, draw a straight line until you intersect the y-axis. So what is the value of your absolute humidity? So let's zoom in.
0.0082.
Yeah. Okay, so let's have a look at the answer. 0.084, slightly off. Okay, slightly off. Again, it depends on how you read your graph. Okay. Next, specific volume. The specific volume, just like I mentioned just now, this is the value of your specific volume. Okay, the one that I highlighted, they are your specific volume. Okay, that's the specific volume. So that means you'll be using the slanting line that was before I gave it a value. I gave it B, that line B. So that is the line. So how do you go about here? Let me change the color of my pencil. So this is your slanting line now. Where is the other slanting line? This is one slanting line. Okay, that's one of it. The other one is here. Okay. Our point of interest is nowhere on that line. It's nowhere on both lines. It's somewhere midway, but we're not sure yet. So what you have to do is draw yourself a line that is parallel to the slanting purple line, parallel to it. Make sure it's parallel. Okay. That is the line. What you have to do next, I'm going to use a black color. You have to measure the distance from that distance to this distance. Measure that distance. Okay? Measure that distance, and then you measure the distance from that line to the other line. Okay? Then you will know where is your what value is that? 8 point something. What? Do you know how to do that? You measure by using your ruler that distance, the distance from here to
I
here.
think it would be 0.875.
75. You did measure
Because
it?
it's in the middle.
It's in the middle. Let me measure. Okay, let me measure. I have my ruler here. That's let me zoom in. That's about. Oh, if you don't want to measure, you can also use the scale here, isn't it? You have the scale there, isn't it? Let me erase this so that you can see the scale. Yeah. Let me draw it again. Let me draw my line again. Is that correct? Is that really that line? Okay. Measure from that. That is about from here to here. That's about what? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's about 9 interval. Okay. So now from here to the next line, which is the next humid volume, that's 9, 10, 11, 12, 13, 14, 15, 16, 17.5, roughly 17.5. So the distance from here to here is 17.5 interval, but the distance from here to that line of interest is about 9. So that means you 9 divided by 17.5, what will you get? Anybody? Let me calculate also.
It's about half. Okay.
Really?
About half.
Why don't you get
0.5.
Okay, 0 about 1.
1.
Yeah. Okay. So your humid volume, if you do that, you multiply by 0.85. Is it? Is it 0 plus 0? Can it be plus or what? What is that value?
First we have to do 0.9 minus 0.85, and then multiply it by 0.51, and then we add it to 0.85. Basically interpolate.
Oh yes, you should be interpolating. So what is that value now? What should you get? 0.8 what? What it should be? 0.8 or what? Or it should be? It's no way. It's not 0.9. It's not 0.85. It should be 8 something. What is it? What you should do is you get the difference here. 0.9 minus 0.85.
0.876.
76. Let's check. Let's check. Yeah, this is 0.9 minus 0.85. That's about 0.9 minus 0.85. It's about 0.05. Okay. 0.05. So you divide by the multiply by 0.51 just now. Remember we got 0.51. That's equals to 0.0255. So your value here is obtained by using 0.85 plus that. You will get 0.5578. I got roughly the same as what you got. 0.875. Sorry, 755. That's how you do it. Guys, this is the simple arithmetic. Anybody not getting how I managed to calculate it? Anybody lost? You want me to repeat it all over again? Okay, let's repeat it all over again. Some of you might not be, catching on what I'm trying to say. Okay, let me repeat that all over again. Okay, the distance from that point, that line, the distance from that line to that next line of your humid volume, the distance we calculated using the interval just now is 17.5. Okay, that distance from here to there is 17.5. But the distance of interest from your point just now to the 0.85 is only 9. So that's halfway actually. It's about 0.51 we calculated. How we got that? 9 divided by 17.5 is equal to 0.51. That's the distance. Okay? So it's halfway. So if you want to know what's the halfway, how to get this value, it will be 0.85 from minus 0.90. The interval will be 0.5. What is it? 0, isn't it? So halfway of that divided by 2 is equal to 0.025. Half of it. So now, in order to get that value, this value, to get that value, you just plus 0.85 plus this value to it, you will be able to get 0.75.
875.
Yeah, 875. Thank you. So that's how you get your humid volume. So let's check our value. Okay, we have over here 0.87. Roughly, it's roughly. Okay, it's rough. It's a rough value, an estimate. Okay, that's the next step. Next, get the enthalpy. How to get the enthalpy? Oops. I'm going to
Use enthalpy line.
Enthalpy line. Okay. Now, where is our point of interest? This is our point of interest. Okay. You go project a straight line. You already have a projected line towards the 100%. When you get the wet bulb temperature, now you just continue with that line. I'm going to get a straight line. I hope I can get a straight line. Okay. Zoom in. What is the enthalpy? This is the enthalpy at saturation, guys. Please bear in mind that is at saturation. So what is that value? Can you zoom in? What is that value? It's about 51, 52, 52.5, isn't it?
Yes, doctor.
Yeah, that is 52.5. But that is at saturation. Your meaning, when you read it from this 100% line, when you read it from the 100% line, this is 100% line. When you read it from the 100% line, that should be the value of your enthalpy, 52.5. And that's the value when it is on. But your point of interest is on the 30% line. It's on the 30% line. So what you have to do, you have to deduct it based on the deviation curve. Where is the deviation curve? Let me get a different color. Brown in color. Okay. Where is your deviation curve? This is your deviation curve. Yeah, that's your deviation curve. Is it exactly on that curve? Our point of interest?
Roughly.
Quite close, isn't it?
Yes, doctor. We can say it's on.
Okay. So your value that you need to deduct is this value, 0.4. Minus 0.4, deduct that value from the 52.5. Deduct it from the 52.5. Right? So deduct it using 0.4. Why? Because this is your enthalpy deviation. Okay, so let me tidy up because you might not be able to see 0.4. This is 0.4. Right? So that's the curve, 0.4. So this is your saturated enthalpy. So in order to calculate it, your enthalpy will be small h. Sorry, it's small h. It's not capital H. Is it capital H or is it small h? Guys, is it small h or is it capital H? No, you can't remember. Let's look at our note. Is it small h or is it capital H? Enthalpy. Enthalpy is capital H. Capital H, guys. It's capital H. Okay? That is at saturation. If you have saturation, then you have that subscript. But if you don't, it's not at saturation, then it's not at no subscript for it. So let's go back to our example. So your enthalpy is capital H. So I'm going to write that using a black My pencil. Okay, H. Oh dear. Why I'm not able to write? Because I zoom in, that's the reason. Okay. Oh dear. Why I'm not being able to write now? What happened? What happened? I cannot write. Okay, anyway, can you calculate the enthalpy, guys? Should be 52.5 minus the deviation value of 0.4. What is the value, please? 52.5 minus 0.4. What's the answer? 52.1, isn't it? Guys, are you with me?
Yes, doctor.
So what's the answer?
We're gonna substitute it by 0.5.
What do you mean by substitute? So
The enthalpy, saturation enthalpy.
the enthalpy is equals to, now I know why I cannot write just now, minus 0.4.
Yes.
It should be 52.1. 52.1. And the unit is kilojoules per kilogram dry air. You look at this unit. Okay? That's kilogram dry air. That is your enthalpy. Why are you deducting this value? Because your point of interest is not on the saturation line. Your point of interest is on the 30%. So you need to deduct 0.4 from that enthalpy of saturation. This is the value that is at saturation. Okay, so you need to deduct 0.4. So let's have a look at the answer. Oh, they give a range because they're not sure whether it's going to be, it's roughly, they give a range. And we got 52.1. This is roughly somewhere within that range. Okay. Any question on how to get the enthalpy? And on how to get the enthalpy? The enthalpy at saturation, this is the enthalpy. Oops. Let me undo that. Okay. This is the enthalpy at saturation. This is the enthalpy deviation. This is the enthalpy deviation. So the reason why I ask you guys to photocopy is you can see how messy our graph is now. It's very messy. Just doing one example, it's very messy. So now let me try to erase it so that we can have a better view. I just erase my point of interest. I need my point of interest, not erase it. Okay, my point of interest is there. That is my point of interest. Okay. And what we did just now, we got ourselves a straight line from our point of interest. That is our point of interest. We got a straight line going to the enthalpy. I need to get a straight line going to the enthalpy scale. Okay, that is my point of interest. My point of interest is the one that I have circled. Going to the enthalpy scale, I managed to get 52.5. Okay, that is at saturation. But my point of interest is not at saturation. My point of interest is on the 30%. So I will go through a line that is 0.4 minus 0.4. That is the deviation curve. This is the deviation curve that passes through that point of interest. It might be on that line, or it might not. It could be on that curve, or it might not be on that curve. Then you have to estimate, just like what we did just now for the humid volume. So in this case, we are assuming that it's directly on that 0.4, and the deviation did, we minus 0.4 from the enthalpy that is at saturation. So that's what we did just now. 5 minus 0.4. Okay, guys. Next, what else is required? You need to get the amount of water in 1 meter cubic of humid air. Wow, the amount of water in 1 meter cubic of humid air. How are you going to go about that? Okay, this needs a bit of calculation. We do have the information that we got just now. We have this over here. Okay, I'm going to, that is our amount of water, humid absolute moisture content. Okay, so let me write that down. 0.0082. Excuse me. That is kilogram water vapor per kilogram dry air. That is your amount of water vapor per kilogram of dry air. Now, what is given? You have 1 meter cubic of humid air. Before this, we managed to get the humid volume. What did we get for the humid volume just now? We got 0.875 meter cubic humid air per kilogram dry air. This stands for humid. Okay, that's A. That's dry. Yeah. Are you guys with me or are you lost? Guys, are you guys with me or you are lost? Nobody?
Here,
Yes.
doctor.
Yes, I hope so. Because this is one of the topic that will be coming out in the second test. Could be this or could be the other one. The one that is on you have psychometric chart, which is humidification, and the other one is mixing and solution. But I think this one will be coming up because that's the one that almost every year will be coming up. Okay, so what is the question all about? The question asks for 1 meter cubic of humid air, the amount of water. Okay, so let's look at this problem. You have 1 meter cubic of humid air. Okay, you want to find the amount of water. The amount of water will be in kilogram of water. You have this information and you have this information. You have that information. Okay, so what you're going to do is we're going to cancel the humid volume, humid air by the unit, or the unit is meter cubic, humid air per kilogram dry air. That is from this the one that I circle here. Okay, so you cancel off your meter cubic humid air. Next, you're going to get the amount of water from your y-axis. Your y-axis just now you managed to get 0.0082. So you're going to use that information in this calculation. 0.0082, that is kilogram water per kilogram dry air. So you will cancel off the kilogram dry air. You end up with the kilogram of water. So if you do the calculation, what will you get for the amount of water? 0.0082 divided by 0.875. You'll be getting 9.37 times 10 to the power of minus 3 kilogram of water. That's how you calculate your kilogram of water. So let's have a look at the solution. Is it the same value? Okay, slight different. Slight different is 9.655 times 10 to the power of negative 3. It depends on how you read your values. Okay, it depends on how you get the humid volume and the absolute humidity. So if it's slightly different, then obviously your answer will be different. Any questions? Guys, any questions? No? You are tired? My God, I'm speaking to myself. Nobody is around.
No, doctor, I'm just trying to understand this.
Okay. Let's look at the what is the problem that you guys having right now. Anybody confused? Anybody need more explanation? Because by next week there will be 1 week off. I would love it if you guys can have a look at the example and try to solve it, but you need to understand the concept first.
Doctor, so humid volume is the volume of vapor only, right?
Humid volume, if you look at the term itself, humid volume means it is wet.
Only vapor.
Sorry. No. Humid not humid volume means the volume of your water vapor plus your dry air. It contain both. Your dry air. Okay? Contain both. That's why it's referred to as humid. You know, the term humid means it's wet. That means the air is wet. That's what it means. So when you say humid air means that the air contain dry air plus water vapor. That's what it means. Okay, it contains water vapor. Okay, let's go look at another example. I'm not going to give you guys a break because you already. If I stop, then you might, you might find it more difficult to understand. Let's try to do this example. Okay. Since we already done one example, if we do another example, it will be something similar to it. That's why I don't want to give you guys a break so that you're having the same momentum. Okay. So let's look at this example. Your A is 32. What temperature is that? What temperature is that, guys? 32?
Dry.
Right, okay. Now, in this case, you are given the relative humidity, 60%. Okay, so let's look at 60%. Where is 60%? That is 60%. Okay. The internet is quite slow because there's a time lapse of when I write it down, and when you perceive it. That is 60%. Okay. Now, what the temperature given is 32. So I'm going to go to 32. Where is 32? That's 31. That's 32. Okay. So if I project it upwards, I need to get this zoom out so that I can get a straight line. Okay, it crossed the 60%. Okay, so that's my point of interest now. My point of interest is exactly on this line. Okay, so the next question is the dew point. Get the dew point. So how to go about that, guys? How to get the dew point?
Horizontal line.
Horizontal line from the point of interest. Okay, that's your point of interest. So draw a straight line. Okay, that's your point of interest. It's not really on that line. I need to draw again. Okay. So what is the temperature? 21, 21, 22, 23, roughly 23 or 23.1?
23.
Yes.
23, roughly 23. Okay. That is your dew point. So what's the answer? Yeah, 23. 23. Now get the wet bulb temperature. See whether we can get 25.5. The wet bulb temperature. How to go about that?
The slanted line.
Slanting line. Which line?
The one. So we draw a parallel line.
Which line?
The one parallel to enthalpy.
Going to the enthalpy. Okay. We draw a line that is parallel to the enthalpy line. Because it's not exactly on that line, we draw a line that is parallel to the enthalpy line. So this is our point of interest. Oops, I keep on doing that. Okay, our point of interest. So we're going to draw a parallel line. So I can get a straight line. Okay. That is our straight line. So what's the temperature now?
25.
Okay, 25.5. Exactly like the one in the solution. Yeah? That's 25.5. That is your T wet. This is your T dew. Yeah. Now you get the idea how to get the dew point and how to get the wet bulb temperature. Is different. Okay, now next. How to get the absolute humidity? Where is your absolute humidity, guys? On
horizontal line.
Horizontal line. Going to where?
Towards y-axis.
y-axis. Okay, get a straight line because that point of interest is exactly on your line,
So it's
horizontal line.
0.018 exactly.
Yeah, so my line is not straight there. So it should be 0.018 exactly because it's right on that line. On that line. Okay, if I can get a straight line. Okay, let's see. Okay, not a straight line, but good enough. Okay, it should be 0.018.
18.
Okay, so that is your absolute humidity. So that's what is written over here. Okay, take note of the unit. Is kilogram water per kilogram or dry air? Next, how to get the specific volume? The answer here is 0.89. Let's see whether we can get the same specific volume. How to get the specific volume?
The green line from,
Where is the green line?
okay, just towards the x-axis, the slanting line.
Okay, the slanting line which says this has that value of 0.85, 0.9, 0.8. Okay, that's the slanting line. Okay, so now the thing is that your point of interest is not exactly on that line. So what you have to do is get it parallel to that line. So I'm going to try to get a parallel line. See whether I can get a parallel. Oops, okay, now my line. That's my point of interest. My line should be parallel to that line. Is that parallel, guys?
Yes, yes.
Okay, so how to get it? You know it's
Now interpolate.
Interpolate. Okay, you have 0.85 and 0.9. So this point should be about less than 0.9. That is less than 0.9. So get the point, let's see, from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's about 13.2 interval. But from here to here, that's about 1, 2, 3, 4. If you continue on, that's 13.
17.5.
Okay, 17.5. We did that calculation earlier, isn't it? So 13.2 divided by 17.5. So what is that?
0.754.
0.7, sorry?
54.
54, thank you. Okay. But the whole distance from 0.85 to 0.9, the whole interval itself is
0.05.
Okay. So how to get this volume then?
Multiply 0.05.
Okay. And so what's the answer? What is that? 0.8 what?
0.0377.
0.0377?
Yes.
What is that?
8877.
8877. Okay. How do you get that just now? Because you know this is the distance.
So 0.0377 plus 0.85.
Can you repeat that again?
0.0377 plus 0.85.
Okay. Right, that's 0.85 from here. Okay. This is obtained using the fact that this is your fraction. The distance between here from 0.85 to 0. Okay, it's messy. It's messy. Very messy. You know what I mean. So how I'm going to make you guys understand this? How to interpolate? Let me see. I know your answer is correct. 877. I know that is the correct answer. That is the answer for your humid volume per kilogram dry air. But how do you go about that? Let me try to explain for those who did not catch your explanation. Okay. 0.9 is that value minus 0.85 equals to 0.05, right? And if you interpolate, this is 0.05. The distance is, I'm not doing a good job here. Somebody, can you explain how to go about it?
Doctor, I think the distance between 0.85 and 0.9 is 0.05, and we have like crust only about 0.7 by 4 of the distance. So we multiply that by the difference and we add it to 0.85.
Okay, the distance with the interval, the distance between 0.85 and 0.9, the distance is how many? Just now we have 17.5, right? We have the interval. 17.5, isn't it? That is
Yes, doctor.
17.5. Yeah. That's the interval that we get when we calculated this. When we calculate this distance to that distance. Okay. So we have interval of 13.5, 13.2, sorry. So what is that? That's what we're doing, isn't it?
Mhm.
Okay. So we got how to do it? 13.2 over 17.5 times 0.05. So what is the answer? You got 0.0337, is it?
Yes,
Yeah,
377.
Yeah, 377. So that plus with your 0.85, that's how you get 0.887. Okay, so the answer is 0.887 meter cubic per kilogram dry air. So if those who don't understand it, I would suggest you try to figure it out. We got 0.887. The answer is 0.89. We got 0.88. Sorry, what did we get just now? 887.
Yes, approximately 0.89.
Okay, that's approximately 0.89.
887.
Yeah.
888, yes.
Yeah. Okay, roughly. So now the enthalpy. How to get the enthalpy? And how to get the enthalpy? How to get the enthalpy?
Enthalpy from the 100% line to the scale.
The scale. Okay. Continue with your your slanting line. Make sure it's straight. Okay. And if we look at this, the
So
scale
that'll
is
be
about
79. 79.
exactly 79. Okay. So let's say it's about 79. Okay. That's kilojoules per kilogram dry air. Okay. So that's 79. But it's not on the 100% line.
We have
It's
to
on the
minus the
60%.
deviation.
So where is the deviation? The deviation is this stuff here.
It's in between, I think.
Okay, so it's in between. So now this is the curve. Yeah.
Between
That means,
0.4 and 0.2.
okay, this is 0.2. That's 0.2. The
That
other
makes
one
it
is
around
0.4.
0.3.
So okay, let's see. Roughly, if you just roughly, is it midway? Is it really
So
midway?
approximately 0.3.
Approximately 0.3. Okay, so approximately 0.3. So that value that you have over here, 79, that is 79. That's for saturation because it's for saturation. But yours is not saturation. So 79 minus 0.3. So you need to minus that 0.3 from the 79. Your answer will be what?
78.7.
Okay, kilojoules per kilogram dry air. So if you look at the answer for this solution, okay, it's a bit off, but that's close. 78, and we got 78.7. Yeah. So do you get the feel of how to use that psychometric chart now? To get the dew point, to get the wet bulb, to get the humidity, absolute humidity, and then to get the enthalpy, and also to get the specific volume. Any question? I think most of the question will be how to get that value. That will be the most of the question, but that is all about interpolation actually. It's estimating actually. You can really how to get that value here. Just estimating. Any questions, guys? Any questions? Nobody? No questions? No question? Okay. 5-minute breaks then. 5-minute break, so we should be back here 3:41.
Doctor, there's one question. Charisma said, how do we get 0.3?
I'll get 0.3. Okay. Okay. Your point of interest is here. Your deviation, enthalpy deviation is the one based on the curve here. That's your enthalpy deviation. That's the curve. Okay. That's the curve. That's the curve. Okay. Where's the curve? Here. That's the curve. Oh dear. Okay. That's the curve. But your point is here. It's not on the curve. It's not on this curve. It's not on that curve. So you kind of estimate. This is 0.2. That's 0.4. So you kind of estimate. Just go parallel to your curve. Say it's about halfway. It's halfway. How do you know it's halfway? Because this is the whole distance. This is your point of interest. So it's about halfway. So it's about 0.3. You just estimate. It doesn't have to be that accurate. It's just an estimate. It's halfway between 0.2 and 0.4. So it's halfway, so it will be minus 0.3. So that's how you get it. Does that answer your question, Karisma? You can answer because the audio is not on. Hope that answer your question, Karisma. Or are you already taking a break? Okay, guys. You want a break? Just now I said you should come back here at 3. Join me back again at 3:40. 5 minutes, 41. Give it 41. Yeah, 3:41.
Doctor,
Yes.
may I ask you if there is any news for this one, the marks?
Not yet.
Okay.
Not yet. Because, marking online, I mean, not marking online, marking using soft copy is really a challenge because it's far easier if you have a hard copy. Then you can sit down and put your heart in it and just mark in one go, maybe. I mean, at least it's faster than marking soft copy. Marking soft copy is really, it's not that that enjoyable to do it actually. I myself, I haven't even finished marking your assignment. I still need to sit down. Maybe during the semester break, I will sit down and finish your assignment. That is only about 37 students. This lecturer for test 1, you can imagine 100 over students to mark. It's very, it's really, really tough to mark soft copy. Okay, guys, it's already 3:42. We will do part of this example, not the whole part. So have a look at this example. You have A at 24 degrees C, that's the dry bulb temperature. 50% relative humidity at 1 atm. The next question is, what is the temperature when it starts to condense? So what temperature are we looking at actually? For part A, what temperature are we looking for? What temperature, sorry?
Dew point.
Dew point, yes, thank you, dew point. The dew point. So how to go about that? We have 24 and 50%. Here again, we do the same thing. 24 is here. That's 24. Yeah? And the percentage is 50%. Well, that's 50%. Yeah, so let me draw on this 50% line curve. Sorry. On this 50% curve. Oops, I'm not doing a good job there. Let me do that. Oops. Very difficult to do it because it's a curve. Okay. See whether I can get my curve line on it. Okay, my temperature is 24. I need to get a straight line. Oh, not a straight line. Okay, that's it. The point of interest is here. I need to get my dew point. So how to get my dew point? Anybody? How to get my dew point?
Do a horizontal line.
Good, thank you. Horizontal line. Okay, so what's the temperature? That's 10, 11, 12. It's about 12, less than 13. It's about 12 point something.
12.9.
I would say 7. It's about halfway, isn't it? 12.9, 12.7, something like that, or 8. Just say something like that. Okay, roughly. So the answer here is given. The answer is 13 because most probably they just. I'm sorry. Oh dear. They just how they estimate it, how they read off the graph. That's 13. Yes, that's one example. You are not familiar in how to get the dew point. So just draw a straight line. So that's about roughly, you can say it's 13, you can say it's 12.8. It's still valid. Yeah. Any question on that? Yeah, we'll not continue the rest of the problem, the example, but we'll be looking at the second example. Oh, we did this. We're going to look at example, this is not example 1, so I'm going to look at example 2. And now, we have a temperature of 30 and 80%. We're going to cool it down to 20 at 1 atm. So we're just going to look at the 30 and the 80%. Okay? What is the absolute humidity at 30 and 80%? Okay, let's have a look at our graph. We have 30 and 80%. So go to 30, that's 30. That's your 30, so 30 straight line. Okay. Where is your 80%? Oh, I need to go further than that. Okay, that's your straight line. Where is 80%? This is 80%. Okay. So your point of interest is here. The next question is the question asks for absolute humidity. So how to get the absolute humidity? How to get absolute humidity?
It's in the right y-axis.
Y-axis. So go horizontally.
To the right.
Yeah, to the right. Let me get a straight line. Okay. So that should be 0.0021, what? 246 roughly. Guys, is it 0.00216 or is it 0.217? Roughly, just give it a rough value.
217, I think.
Okay, 0.0217. Okay, roughly. Okay, the unit should be in kilogram water per kilogram dry air. So let's see what's the answer. 0.0217. Okay, we got it. Okay. Next, what do you need to find? Dew point. Get the dew point. Where is the dew point? How to get the dew point? Anybody?
Same horizontal line, but
Horizontal
to the left.
Okay, to the left, to the 100% curve. Yeah. So what's the temperature?
Roughly 26.
Roughly 26. Okay, that's 26. So let's have a look at the solution. 26.2, the solution give a value of 26.2. Well, we got 26 close enough. How about getting the wet bulb temperature? How to get the wet bulb temperature? Yeah, how to get the wet bulb temperature?
Draw a line toward 85, the one with saturation dry air.
Okay,
Enthalpy line.
towards the enthalpy line, you mean? The enthalpy scale.
Yeah.
Okay, using the enthalpy line. So this is your point of interest. So draw a straight line towards that line, but not towards to the scale. You stop at the 100%.
100%,
So now,
yes.
yeah. So now your wet bulb line, your wet bulb temperature is 27, isn't it? Okay,
Yes.
let's see. 27, is it 27? Yep, 27.1. Over here is 27.1. Well, that's okay, 27. Next, get the humid volume. Humid volume. So your point of interest again is that circle. Where is that? How to get the humid volume?
Draw a parallel line to the 0.9 line.
Okay, let's undo that. I need to, this is 0. Oh dear, 0.9, 0.85. So parallel line, so we're going to draw a parallel line to 0.9. Is that parallel? Okay. So again, you have to do the calculation. Just now, 0.9 minus 0.85, we managed to get 0.05. And that distance just now is equals to 17.5, right? For 0.05 interval. But what is this interval now? I tell you what, calculate this from here. That's 1, 2, 3, 4, 4.5, isn't it? We're going to get
Yes.
0.9. Okay, 4.5. So 4.5, sorry, 4.5. Erase that. So what is going to be your value of your humid volume? You do the calculation. I'm not going to calculate it again. I have done that before this, so you should know. It should be 0.8 what?
Uh, 0.887.
887. Okay, for those who still don't understand how to get this, try to ask, okay, if you don't get it, it's 0.
Doctor,
Sorry,
for the 4.51, I think if we substituted it, it won't get us the right answer.
sorry, 4.5 again?
Yes, we have to substitute it by 17.5.
Substitute 17.5. 4.5.
Subtract, I mean.
Subtract. Oh, you mean you start from here? From here? Sorry, no. Start from the 0.85.
Yes.
Okay, no problem. 17.5 minus 4 is that's going to be 13.
13.
Okay. So what is that then? So you just do the calculation either way. If you start from 0.85, then it be plus. But if you start from 0.9, then it be minus. It's still the same thing, isn't it? Do you get what I mean?
Yes, but the ratio will be different.
Okay, okay, I get it. I see. Okay, so 0.887. So let's see what is given here. 0.88. So that's it. That's 0.87. Okay, we got it. We got 0.887, but this is 887. 0.87. Fine. So that's quite close also. And next, enthalpy. How to get the enthalpy? How to get the enthalpy? The last part of the question, how to get the enthalpy.
It's 85,
How do you know it's 85?
but we're gonna subtract it by the other line.
Subtract from the other line. Okay. Now, first thing first, extend from 27. From your point of interest, actually is here. So we're going to extend it to the enthalpy scale. So if you read this scale is about 85.7 maybe. Okay, that's about 85.7. But that is for saturation. You need to deduct from the enthalpy deviation. And where is your enthalpy deviation? This is your enthalpy deviation. That's that line. That's curve actually. That's that curve. Where is the other curve? Here is the other curve. This is another curve. This is another curve. Okay, this is 0.2. This is minus 0.1. So it's about maybe roughly. Can you say it's midway? Can you say minus 0.15? Guys?
We can say it's closer to 0.1.
Okay. So give it an estimate. Roughly it's about minus 0.1, maybe 1 closer. What then? Minus 0. What?
Doctor, actually there are two lines. The one that negative 0.1 and negative 0.05. I think they're at the same point.
But we are here. Our point of interest is here. Point of interest is here. So
I mean, at the interact point, we have a line crossing it.
sorry, let me erase this. Okay. Let me erase it. This is the line 0.1, isn't it? That's 0.1, isn't it? That's 0.1, isn't it? This is 0.2. 0.2.
Yes, but our point
Point.
is at 0.5, 0.05.
This is 0.05. This is 0.05. That's 0.05. That is 0.1. That is 0.02. If you follow that line, 0.5 is where? 0.5 is starting there. Right. That's the line. That's where it starts. 0.1 start somewhere beyond that. Okay, that's it. This one 0.2 is starting going there. So our point of interest is between 0.1 and 0.2. It's not 0.05, isn't it?
I mean, if we remove this line, we're gonna see our point of interact is actually crossing a line. This one, black line behind it.
The problem is I can't see what are you trying to point. Where, which line? Let me see.
This one.
The thing is I can't see where's you're pointing to. Let me see. Let me clear this up. Let me clear this up so that maybe we can see better. Yeah, let me clear it up. Okay, so our point of interest just now is here. That is our point of interest. Okay. So what this is minus 0.1. That is minus 0.1. And this is minus 0, sorry. This is minus 0.2. The curve here, this one is, the one here is 80%. It's exactly on the 80%.
So this one for relative humidity.
80% is relative humidity. This is the minus one. Minus 0.1, minus 0.2. Okay, so now we are between, exactly between, isn't it?
Yes, clear, doctor.
Yeah. So it's minus 0.15, isn't it?
Yes.
Okay, so minus 0.15. What's the answer? 85.7 minus 0.15. What is the enthalpy?
Uh, 85.55.
0.55. Okay, let's have a look at the answer. 85.5. The answer is 85.5. That's close. Okay, you get the how to use the graph now, guys. You have too many information in one graph, but if you know how to handle it, it shouldn't be a problem. The thing that most of you might be having a bit of confusion with how to get the humid volume. Most probably that is where your confusion is. The rest, I think, is quite easy. Okay, guys. Any questions so far before we stop? Any questions? I've been doing a few problems already. I mean, few example. For example, in how to read the graph. This is our last lecture before the break. So I would suggest you try to use this graph. You photocopy a lot of it from your textbook and try to solve some of the problem at the back or look at the example during your break to get familiarize with the graph. Because the more practice you do, then you get better at it. Okay, guys? No questions? No questions?
No, doctor.
No, good. So thank you very much. I mean, it's quite a long way before your break, but this is only Monday, isn't it? So you have Tuesday, Wednesday, Thursday, Friday, Thursday. So we'll be seeing each other 2 weeks from now, because next week is going to be your break. And I'll be finishing off marking your assignment. And I'll be giving you assignment number 2, which doesn't include this psychometric chart, just the calculation for the enthalpy for phase change and without phase change. I'm having problem with saying phase change. Okay. My tongue got twisted.
Doctor,
Okay. Yes.
can you show the QR code again?
QR code again. Oh, yes. Let me try to unshare this. Okay. Where is the QR code? Oh, let me try to get my QR code. Okay, hold on. For those who already, oh dear, where is the, okay. Hey guys. How many students do I have today? Is it some of you just